Hello and welcome to Evolving Analytics in a Data Platform. My name is Blanca Garcia-Gil and I'm a principal engineer at the BBC. Before we start, I'm going to tell you the motivation behind this talk, and there's actually a story of migration at an organizational level, and how sometimes in engineering teams migrations are not seen in such like a positive or kind of challenging way, because it's seen as a way of kind of lifting and shifting existing technology into a new platform. But in our case, we tried to see some positives into it, and we thought, well, this is kind of an opportunity for us to start all over. And the things that we've learned from our previous platform and the frustrations we had, we wondered, what could we do differently this time? And there were many, many things. So the agenda for today is going to be, first, I'm going to introduce you to the BBC. Might surprise you with things you didn't know. Then why the data platform in an organization like this. Then we'll look at the architecture of the microservices platform that manages our analytics, okay, and what we came up after with the architecture. There's another talk that I did at QCon last year to go through that whole re-architecture process. And then we'll introduce the concept of failure modes, which is a term used within observability, and the different types of failure modes. And then we'll kind of apply those to this architecture that I introduced earlier and show you what things we were able to design into it with applying the lessons that we learned. And then what things came up afterwards and we had not been able to kind of prepare or forecast for them, and what we did. And then we'll summarize all the things that we learned together today in the conclusions. So first things first, the BBC. If you're an international audience especially, you might be quite familiar with our news, broadcasting, or our radio, but there's a lot more than that to the BBC. We have very popular sports sites, and we do live sport retransmissions. We have a TV catch-up service called iPlayer for users and audiences in the UK. And we now have also a podcasting service called BBC Sounds. But in the last year, with everyone being kept at home, there are other services that have come at the forefront of the minds of our users. And that has been services like BBC Bitesize, which is always there, helping students revise for national exams on a yearly basis. But it's been kind of popular because we added more content to help students keep up with the lessons that they were kind of missing at school and kind of revise on a daily basis. And I always, add here the BBC Weather Service, because if you are like me and have lived in the UK for quite some time, you will have learned that we just love talking about the weather. But then again, we are a global broadcaster, but we're actually in the UK, we're a public broadcaster. And what this means is that we are funded by a license fee that is paid by every UK household. And we are meant to be, as part of our remit, reaching all the diverse audiences, backgrounds, communities that make up the UK nations and regions. And as part of our mission, we have 3 core principles, which is we have to inform, educate, and entertain our audiences. Now onto the data platform. Why would an organization like the BBC, which is used to doing almost one-way broadcasting, have a data platform? Well, we've been wanting to kind of shift from where we were into a place where we understand our audiences better. And this is to offer, this is for various reasons. One of them is to offer everyone something that they like, not just a very set few, but also maybe increase the breadth of services that people are aware of. So in turn, they make the most of what the BBC has to offer them. After all, they're paying us a license fee, but also it helps them realize the value of what the money that they pay us gives them. On the technical side, what does this mean for the data platform team where I work in? Well, we are in the big data space. We are fully on the cloud. We are on Amazon, and we design microservices architectures to ingest data from various sources. one of the sources. Our highest scale is the analytics data, and this is the example that we'll be following on today. This ingestion pipeline means that we receive billions of messages every day, and over time these messages accumulate and are stored within what we call a data lake, and this is essentially just cloud storage, where all the kind of data has been validated and has gone through the processing chain ends up. And this data lake is a historical archive, and right now we are already at petabyte scale. What does the architecture that we migrated into look like these days? Well, at first glance, you might see, actually, it does look quite complicated, but we'll be breaking it down bit by bit, okay, and focus on how, how we operate, how we operated, what things we have that helped us investigate issues. The first row at the top is the ingestion chain. Okay, and the main microservices that make up this architecture. So if we start with the left-hand side, where we have that kind of red thing that looks a bit like a bucket, I said we were in Amazon, so they are all Amazon icons. We have cloud storage on S3, that's called, where we receive what we call the ingest logs. So from our analytics supplier, they deliver us they deliver to us files on a regular cadence. Okay, and we know when we expect these files and even what the file names are meant to be. And whenever a file gets into that storage, there's an event that gets kicked off. Okay, and what this event says to the rest of the kind of the next element in the system is there's a new file that has been received and is ready for processing. So this event goes into a queue. Okay, so many events will be lined up in that queue, and then there is a Java application that we call the job submitter that will read each one of those events, validate the name of a file. That is something that we actually expected to receive, but it's essentially very, very minimal stuff that it does. And then it passes on to the next one on the chain. And this is not really so much a microservices. It's actually a MapReduce cluster. But what it does is it can process multiple files at a time. And what it does is it actually goes into the contents of each file and validates them against the model. Okay, so we do what we call model driven validation, and this model kind of defines what are the different fields that are expected in file, what are accepted values. If not, it will reject the file and notify us. And it also compresses data when it's written to the next chain. And it also does what we call enrichments, which are essentially transformations on some of those fields. The fields can contain locations, they can contain postcodes, they can contain dates and times, and sometimes the format that they come in is not the most useful. So they're actually transformed and then written out. And then these files are stored in what we call the intermediate data lake. We call it intermediate only because it's for use within this microservices architecture. Our users of the data, they don't have access to we call it's still in a bit of a raw format, even though it's been validated. It's not in the most optimum way to be kind of queried and analyzed on. So there's another process down the line called the data summaries. And what this does is it takes those files and it knows a bit more about the data and about the expected use that reports or dashboards or data analysts will make of it. And it does aggregations and summaries. And those aggregations and summaries are then written out to our data warehouse. And for that, we use Amazon Redshift. And it's essentially a big data database, and it does perform queries at scale. And then the historical archive of that data ends up in the data lake. Okay, in Redshift, we keep a subset of that data because that's normally the use cases we've had. And they will be, data analysts, data scientists, dashboards, all sorts of users internally at the BBC that will be using that data to inform decisions, okay, to create reports. There will be machine learning algorithms from that data as well. So it's become quite core to the BBC now. when we were having discussions about the design and the makeup of this pipeline, for me, there was a key question that I was looking for an answer. And for me, it was, are the metrics, are the dashboards that we have telling me everything that I need to know? Okay, because my experience with the previous architecture was that operating it was quite painful. It took ages to dive, into the issues. Sometimes it was frustrating because you wouldn't find the data to actually tell you what had been going on. Okay, and I had learned also from experience, and others in the team had learned from experience, that not all the bugs are in the code necessarily. Okay, with microservices architectures, the more microservices you have, the more cracks that can appear in your system. And also because these microservices usually don't operate, in isolation. Our architecture is connected to, our suppliers in a way by them sending us files. Then every point that you can connect to another system, there's another potential crack. So you have to be very aware when you are designing. Now we're going to focus on failure modes. And this is a term used in observability. And there's various failure modes, and we're going to explain to them first. The first one is what is called known unknowns. And what are these? Well, these are the failures that we can predict, that we look at a system, or we're looking at some code and thinking, oh, this might fail here. And you can provide a safety net for them, or you can log it, you can track it in a dashboard, you can alert on it. Okay. And these are great because they will, you know them beforehand. So make your life a bit easier by adding them into your system. But then there's another element of failures that will probably happen over time that you won't know about. So by catering for these known unknowns, the question is, do you have enough information for those future failures? And are those metrics giving you everything you need? In our experience, well, no, not really. So there's another mode of failures, and these are called unknown unknowns. What these are is, well, we know every system will fail at some point. Every production system that handles quite some load, and just think beyond the experience that you have, and we've kind of you realize that you can't control everything. You cannot predict all the failures, and once you accept that, then it opens up a new way of thinking and a new way of kind of tackling issues. And the question is about, do you have the data? Do you have the tooling that is going to allow you to investigate issues that haven't happened yet? I like to show this image from the BBC TV series Sherlock, because there's something, it shows Sherlock and Watson, and Sherlock very, very frequently says to Watson, you see, but you do not observe. And I think this very much relates to observability, that you will have the metrics, you will have data, but sometimes you will still need to cater for kind of that unknown thing, or kind of look a bit beyond. And what I like here is that most people will focus on both of the men at the forefront of the photo, but if you look in between them, there's actually a hidden picture of a woman in the background. So let's go back to our architecture and the known unknowns that we learned from and we designed for when we were designing the architecture. And I've summarized them in this table. The first one of them was, well, things used to fail in a big bang fashion, and we used to just kind of lose a whole day's processing of data. And this was very painful, because when you're working at a scale of billions, then it's harder to recover, it's harder to investigate, everything is just, more difficult. So in this case, we said we have to be able to isolate failure. Okay, so each one of the microservices that is made up in the architecture, if it comes down or we have to investigate it, we have to take it out of the processing chain, then it doesn't affect the others. Okay, they can operate independently. And that's been a huge, huge bonus. The second issue was well, we encounter issues and we find that we just don't have enough data to investigate them. We look at the logs, we look at the metrics, but there's no conclusive kind of thing that we can say about what's caused the failure. So in the data space, there's a term called lineage store. And what this is essentially being able to track all the data that you receive and that goes through your system and the different stages that it goes through, so that if anything happens, you are able to kind of go into this historical archive of events and see at which point things failed. Okay. The third one goes back into kind of failure and the ability to replay. So we have built some utilities in our new architecture that help us replay data. Okay, and this happens at various stages of the processing chain and has been tremendously useful and made our lives really easier. And then the fourth one is just being able to answer a simple question in a distributed system. Sometimes it's just not that straightforward. So you have to always focus, how do you know that things are running? Like, do you really know if things are running? And in this case, we still have metrics, we still have dashboards, but the lineage store has given us that added granularity that we needed to be able to kind of answer that question on a more detailed level. So let's go to architecture and see, where those 4 items kind of fit into. So the first one is about isolating failure. Okay, I've kind of marked the 3 main microservices of the architecture, and each one of those can fail independently. Okay, that's a given, and we're able to investigate issues. We're able to deploy them, independently, and that's been huge, for development and triage. The second one is knowing at which stage, the data is of the processing chain, and I've shown in number 2 at the bottom. That's where the lineage database is. Okay, and all our microservices are actually writing to this lineage data store so that we can keep track and audit those events. Number 3 is the ability to replay data. So we have a utility that we call resubmitter. And if we want to replay some data, reprocess it, essentially what we do is we just add an event to a queue that says the file and the path that we need to reprocess. And there's a Java application that just kind of drops the event into the start of the processing chain. Okay. Separately, at the end of our processing chain, where we have the data summaries, that's an Apache Airflow application. And if you are familiar with Apache Airflow, it also has out-of-the-box functionality that will help you reprocess and replay data. So we use that quite heavily as well, but we haven't had to build anything on top of it. And then the fourth one is being able to answer the question of, is your system's really running? So I haven't added here the metrics and the dashboards. Don't forget those. You still need them. But then the lineage database, that's kind of the core thing. Now we'll move on to the other more interesting, at least for me, kind of unknown unknowns, okay, and how you kind of can prepare yourself for those. There were 2 main things that came up for us. One was, we were receiving data from a third-party supplier, okay, and while there was an agreed cadence to that data and data formats, we still found that there were, plenty of late data arrivals, and that we could help by keeping track of the data that was missing, and also, being able to inform, downstream to our users and our business when things were not running as expected. So in this case, we had the lineage store that keeps track of the events and also what data is missing. But we took it one step forward, and we ended up automating it to save ourselves some more work. So we created a serverless function written in Java, and what it does is periodically queries the lineage data store for missing files. And if there are any missing files, it will alert us, but also it will create a ticket, open an incident ticket with our supplier, and give them the exact data that they need to start the investigation. So that has been useful for us and also useful for them. And then the second thing that kind of has come up over time is when you operate software products, the term service level agreements or SLAs always comes up. And service level agreements are essentially an expectation that is agreed with your stakeholders and about what is the kind of the availability, the promised availability of your service, but also, when incidents occur, depending on the different severity levels, what is kind of your promise for fixing them, okay? And in our case, we have that like every other live product, and we have the data in the lineage store. But sometimes, having to connect to a database, knowing, and understanding the data model within that database and being able to write the SQL already kind of narrows down the number of people that are able to make sense of that data. So there was an engineer in our team that had a great idea, and he said, how about we abstract that and we kind of create a command line utility that can answer simple business questions. So taking inspiration from the Amazon command line interface, he kind of wrote a utility in Python to be able to answer the service level agreement question. So that command line utility has become a huge success in our team, to the point that every engineer onboarded now will install it, okay, and even business analysts will use it at some point, and it just produces reports, for us. And then it makes us, being able to access that data very easily without having to kind of remember, okay, how, it links together and how things are laid out internally. It's really, really helpful. And back to architecture, where are these kind of holding from? Well, the lineage store at the bottom. So it's been quite key for us to tackle those unknown unknowns. And first, well, the serverless application, the Java application that, queries and alerts for missing data, and then the command line tool, which I personally love. And I recommend that you look into. There's some, frameworks in Python that are really make your life really, really easy to do these things. And now we've reached, we're close toward the end, and I'm going to summarize the things that have been key learnings for us. So the key learning has been, invest in shared tooling. Okay, it's benefited us in many, many ways. Okay, sharing knowledge across our team. Okay, we used to have only 2 or 3 people that understood, the architecture, were able to kind of dive into issues and triage them. That's not a way to kind of have a shared responsibility of your production system. And also because when you have, different microservices architectures like we have, we might be sometimes working in other systems. So when you have to, go back into, a system that you haven't perhaps, worked on for a while, there's a lot of detail and context that has escaped from your head. So it helps, to kind of have that tooling to help us, very quickly get the answers. Then being able to replay the data is also another core thing. Okay, there's always going to be failures. So make your own life easier by automating this, or actually building, something that allows you to do it fairly quickly. The most important one for me has been the time that it takes now to triage and then kind of solve incidents. Okay, back in the day when we had big bang failures, what meant was not just that we lost a whole day's data, but that we have, more than 1 billion of records that we had to kind of dive through to understand what has been going on. And it was very time consuming, energy consuming. You sometimes didn't really, find what was going on, okay, because the sheer amount of data. And in this case, having that lineage store, having, the validation, the per field validation has really, really helped us with it. And then the last one is the ability to use that data to answer business questions and reports. Okay, it's given our team confidence in the work that we're doing, but it's also given the business confidence that we kind of have under control. the things that we can control. And before we finish, I wanted to leave you, with a question for yourself. I'm sure many of you have been working on products, on software products that are in production. And if you are part of an on-call rota, you have a phone that alerts you when things go bad. And, try to see, are these alerts, do they have a pattern? Are there things that you could automate? Could you develop some tooling? Measure, what the impact of automating that is, and show it, to your business, and make a case for it, because it will not only save you from perhaps being woken up, but also it will in turn save the business money. So there's something to think about there, and it will save you from frustration. So what are the things that if you could change, you would design differently? Thank you.
So thank you again, Blanca, for a great presentation. And thanks to everyone who's already asking questions in the chat. We'll try to get to as many of those as possible. I wanted to start by asking Blanca two related concerns you brought up that I think everyone has kind of encountered, that there are people that just don't have good knowledge about the system that might be somehow involved in an incident. But also when you get brought back in to help triage and troubleshoot a service you haven't worked on in a while and it fails and you kind of have to get refamiliar with it again. What did you do to specifically take care of those two problems, and to disseminate not just here's the problem that's happening, but also here's a potential solution. Here's what the system can help tell you what you should do to fix it.
That's a very good question, Thomas. So for every product that we release into production, we usually have a kind of like a set of documents that we put together, and one of them is called runbooks. Okay, and what a runbook contains, it has like a defined structure, and it contains things from architecture diagrams to who is the team that owns that product, who to contact, links to that support rota that I mentioned, and also some of there are known issues in the system that might crop up now and then. It contains the instructions on how to fix them and how to go about triaging them. So that's almost like offloading from our brains that context to a place that we all have kind of a shared space, and we also kind of update them over time as we go. So they are incredibly useful.
Gotcha. I've seen a couple people already ask about the lineage store and item potency for the replay. So can you talk about the lineage store a little bit?
Yes, so the lineage store is just literally a store of events. Okay, it's called lineage because in the data space, lineage is about kind of marrying the different kind of stages of your data in the data journey. Okay, so I've shown like a cascading of microservices. Okay, and the reason why this is called, the lineage is important for us is I showed at the end of our ingestion pipeline there is a data warehouse, and where it gets really interesting is that a person a lot of the times will be querying that data and trying to make sense of things, but they might come to us and say, actually, I'm trying to analyze the performance of a program, a video program in iPlayer, and I don't understand why this data, is showing this. This doesn't maybe look right. And that is when we're faced all of a sudden with a question of kind of explaining to them what was the raw file that came with that data and the different stages of transformation. And we have to be able to kind of dig through that and kind of join all those points. So that's why it's called lineage. Okay. In other systems that are not data platforms, you might have just, a stream of events or traces. Okay. It's the same concept. So this is just kind of the very specific example for a data platform.
Gotcha. And then when you have to replay those events, how do you ensure the item potency, that you're not duplicating everything as you replay them?
That's a good question. I believe, okay, there's different kind of strategies that in the different kind of steps. And I know in some of them, there's some cleanup that has to happen before you can actually replay the data, because otherwise you'll be creating duplicates. Okay, so that's why, when you are automating things, sometimes we think, oh, it's just about maybe dropping an extra event. But actually, if you sit down and write down that process from start to end, you will realize that there's a lot more to it. Okay, and what helped us realize that was actually those run books where we had the step-by-steps, and they became very complicated over time. It was like, this is not good. You don't want anyone, to be stressed out having to go through such detailed things.
And so do you use that knowledge to say the run book has gotten too complicated, we can get the system to help us and simplify the steps we have to do to replace it, or just eliminate it entirely?
Usually, yes. For I think more than a year now, we have been also doing what we call post-incident reviews. So when there's an issue in production, once we go through all the triaging and the fixing, the people that have been involved in kind of solving that get together and do almost like an analysis, like a retrospective analysis, to try to learn what things they did, what things maybe could be done differently, and what things actually could be fixed more permanently. So for issues that are maybe a one-off, you would add them in the run book. Okay, you usually don't want to have there things that happen all the time. Okay, that's a smell for something that is crying for automation, really.
Right. I think someone did want specifically what was the technology you used for the lineage store? Is it Kafka? Is it Event Store?
Well, for us, it's not really streaming. Okay, it's just a relational database. Okay, we started with something really, really simple, but you can build, as far as you would like. It depends on how often and what is kind of the use cases that you're gonna have. Okay, for us, it started being a place where we could just store things. I think in retrospective, we were not anticipating using it as much, or having maybe a real-time processing applications down the line. Okay, but as I say, it can be anything you would like.
Yeah, I mean, that's, I think, typical. So we make this little small thing, and then pretty soon it becomes a pretty regularly used part of the system. So how does the analytics platform that you guys created help, and I guess the observability part of that as well, facilitate shared ownership? So you have a distributed system, teams all have their own problems. Is there something that helps them all see, here's the state of the system, here's how we all work together, and when one little problem happens in one part of the system, it can have a catastrophic effect somewhere else?
That's a very, very good question. So we try to have regular knowledge sharing sessions in our team. Our team working in the data platform is about, I think, 25 people, okay, including engineers and all of the other disciplines that we need. And we divide ourselves in kind of smaller groups or squads. People sometimes kind of shift between squads at times, but it's quite important for all of us to understand what the other squads are working on, because as you say, everything is very interrelated. So we do regular demos. Okay, we also do pieces that we collaborate, not just between our squads, but also with our stakeholders, because sometimes they might have needs or they might be suggesting an improvement. And we, in the past year, we have said to them, come and join us for a few weeks and we'll build it together with you. And that has been amazing because we have learned a lot from them, because they're the experts in the data.
Yeah, I think that's one of those things I like to see is cross-team ownership. So the workflow you described was very clearly for the data pipeline, but some of the ideas you talked about are applicable to any other type of system. So like the idea of you have unknown unknowns in the system, did you explicitly put anything in place to help you surface those as they came up, or was it all reactionary that you saw this problem occurring and then you had to go back and find a solution?
So the thing with unknown unknowns is that you can get together with a group and just think of all the possible failures, but it's probably not worth your time taking steps to action them until you know whether they're going to happen. So usually teams go through these exercises in design phases that you get, a number of people in a room together with different angles of experience, different ways. That the diversity, of experience is very key for this. And people will suggest ways that things might fail. And then it's about putting that list together and then thinking, actually, what is, the possibility that this will happen? And then you begin kind of prioritizing them, but also de-risking some of them, because you realize that they're just, very, very unlikely. But I think it's about keeping those things in mind, and you will not be able to prepare for everything. So we still deal with a number of life issues. Okay.
Yeah.
And it's part of the learning process, being honest.
Yeah. Someone had a question about, you mentioned having a relational database, and I think people tend to think those aren't efficient. Do you have any throughput considerations if you're putting all the data into the relational database, or does it keep up just fine?
For us, it keeps us until now. It's kept up okay. We've been in production, I think, for over 2 years now. Okay, and what I've learned is that as the scale of your problem changes, the ways to solve it also changes. So we might need to review that. Okay, and in the last year, for example, we have had to do a second migration of our infrastructure for our data warehouse because it's grown so big that it wasn't meeting the needs. So we've had to invest in that, but it might also happen in the Lineage store.
Yeah. Well, I guess one of the last questions I had was, early on, you said you had a goal of keeping things simple. How do you find a balance between, I think they'll see a trade-off between really simple, but also being useful, and it has to be able to do more. Do you feel like you've achieved that with some of the solutions you've put in?
Well, one thing that it has helped me, I think, focusing on simple is learning about the use cases. Okay, what are the use cases from the business and your stakeholders, and getting to know what are the pain points, and starting with those. Okay, and then over time, probably most of the things that you thought about were not needed. Okay, but also there is an element that when you write the first time, the first implementation, the first version of something, everything might feel very simple, very clean. And as you add to it, you begin accumulating the dreaded tech debt.
Mm-hmm.
Okay, so you have to kind of, as you keep working on it, not just address it, but also have conversations with your stakeholders and with your business about the impact of it on the team, okay, on the product. And if you have a substantial business case, then it's time to tackle it. So that's another whole lot topic for another time, perhaps.
Well, that's a good segue, because unfortunately we're out of time right now for this session. We invite everyone to continue the conversation with Blanca by joining the Zoom room. There's a link in the chat right now, or if you missed that, you can go back to the InfoQ Live schedule page and click there. That'll be open, and we invite you to turn on your camera. It's a very informal conversation. Chat with Blanca, ask her any questions you may still have. And so final thank you to Blanca Garcia-Gil and for everyone for attending. Hope to see you at the next session.
Thanks.